All right, strap in, everyone. Today, we're going deep on NVLink.
Ooh, yeah. I've been looking forward to this one.
You've sent us a ton of stuff, articles, videos, even some code.
Oh, wow. Someone did their homework.
It seems like everyone's heard of NVLink, like it's this super highway for GPUs, but no one really knows what that means.
Yeah, that's fair. It's a powerful technology, but can be a little mysterious.
So where do we even begin? What is NVLink, and why should anyone care?
Well, imagine this. You're trying to train a massive AI model,
Okay, I'm imagining.
and it's just taking forever on a single GPU.
Uh-huh, I feel that. Some of those models can take days or even weeks to train.
Exactly. But what if you could link together multiple GPUs to share the workload? That's where NVLink comes in.
Ah, so it's like teamwork for GPUs.
Precisely. NVLink is a high-speed communication pathway that lets NVIDIA GPUs talk to each other directly. It's like having a dedicated express lane just for them, bypassing all the usual traffic.
So it's faster than using the regular connections on the motherboard.
Way faster. We're talking about speeds that make PCIe look like a dial-up modem.
Whoa, okay, I'm intrigued now. How much faster are we talking?
The latest generation of NVLink can hit a mind-blowing 900 gigabytes per second per GPU.
900 gigabytes per
Huh.
second. That's just dot insane. I don't even know what to compare that to.
Think of it this way. You could transfer an entire Blu-ray movie in a fraction of a second.
Okay, now that's a speed I can understand. But I gotta ask, who actually needs this kind of speed? Is this just for, like, hardcore scientists and researchers?
Well, they're definitely big fans of NVLink, but it's becoming more and more relevant for a wider range of applications. Think about things like AI training, rendering complex 3D graphics, and even high-frequency trading. Anything that requires massive amounts of data to be processed quickly can benefit from NVLink.
So it's not just about speed, it's about handling those huge data sets that are becoming more and more common.
Exactly. As the amount of data we generate continues to explode, NVLink is becoming an essential tool for keeping up.
That makes sense. But one of the things that confused me when I was reading about NVLink is, how is it different from just using multiple GPUs with PCIe? I mean, my motherboard has multiple PCIe slots. Why not just use those?
That's a great question. And it's a common one. See, PCIe is a great general purpose interconnect, but it's not really designed for the kind of high bandwidth communication that GPUs need when they're working together. It's like trying to fit a square peg in a round hole. NVLink, on the other hand, is specifically designed for this purpose. It's like having a custom tailored suit. It fits perfectly and brings out the best in those GPUs.
So even though PCIe is constantly getting faster with each generation, it's just fundamentally not the right tool for the job when it comes to GPU communication.
Exactly. It's like comparing a bicycle to a Formula One race car. Both can get you from point A to point B, but the race car is designed for speed and performance in a way that the bicycle just can't match.
Okay, that analogy makes it much clearer. So NVLink is like the Formula One of GPU interconnects.
You got it?
But it's not just about speed, right? I read that NVLink also changes the way you write code for GPUs. Something about a unified virtual address space.
Yes, UVAS. That's a key part of what makes NVLink so powerful. It's like, imagine you have a team of people working on a giant puzzle,
Okay, I'm picturing it.
and each person has their own little section of the puzzle to work on. But what if they could all see the entire puzzle at once and easily share pieces with each other? That's essentially what UVAS does. It lets all the GPUs connected via NVLink share a single, unified memory space.
So instead of each GPU having its own little island of memory, they all have access to one giant pool of resources.
Exactly. This makes it much easier for developers to write code that utilizes the combined power of multiple GPUs. They no longer need to worry about manually transferring data between GPUs. It's all right there, ready to be accessed.
That sounds like a huge advantage for developers. It's like removing a whole layer of complexity.
It is. It allows them to focus on solving the problem at hand, rather than getting bogged down in the nitty-gritty details of managing memory and data transfer.
This is all really fascinating stuff. It feels like we've only just scratched the surface of NVLink, though.
Oh, we've barely begun.
But before we dive deeper, I'm curious about those cool-looking NVLink bridges I've seen in pictures. What are those all about?
Ah, the bridges. They were the early embodiment of NVLink, a very visual representation of the direct connection between two GPUs. But as NVLink has evolved, it's gone beyond simple bridges.
So what are we using now?
Now we have the NV switch chip, which is like a super powered network switch for GPUs. It allows us to connect not just two, but dozens, even hundreds of GPUs together.
Oh, hundreds. So we're talking about building a supercomputer right on your desk.
Well, maybe not on your desk just yet, but the potential is there. And it's not just about the number of GPUs, it's about the speed at which they can communicate. With NV Switch, each GPU can talk to any other GPU at that same blazing fast 900 gigabytes per second.
Okay, my brain is officially melting trying to imagine the scale of that.
It's definitely a lot to wrap your head around.
But before we get too far ahead of ourselves, I think it's worth taking a step back and looking at how this technology has evolved over time. You mentioned the bridges and NV Switch.
Hmm.
What was the journey that led to where we are today?
That's a great idea. Understanding the evolution of NVLink can give us a better appreciation for its current capabilities and where it might be headed in the future.
All right, then let's fire up the NVLink time machine and see where this journey takes us.
So picture this. It's 2016, and the world's getting its first taste of NVLink with the Pascal architecture.
Ah, Pascal. That brings back memories. Wasn't that around the time they released the GTX 1080?
You got it, that's the one. And while gamers were marveling at the 1080's power, a whole other revolution was brewing in the world of high-performance computing.
Right, because NVLink was kind of flying under the radar back then, wasn't it?
It was. But for researchers and scientists dealing with massive data sets, it was a revelation. Suddenly, they could connect two GPUs directly and see a significant boost in data transfer speeds.
So how much faster was this first generation compared to using PCIe?
It's hard to give an exact number because it varied depending on the specific tasks, but let's just say it was a considerable jump, enough to make people sit up and take notice.
I can imagine. So what happened next? Did they just keep making it faster?
Pretty much. With each new generation of NVIDIA GPUs came a new, improved version of NVLink. Volta, the second generation, doubled the bandwidth, bringing it up to 256 gigabytes per second.
Wow, so things were already getting pretty crazy at this point.
Oh, yeah. And then Turing came along and doubled it again, hitting a whopping 500 gigabytes per second. It was like they were on a mission to break the sound barrier of data transfer.
It's amazing how quickly things were progressing. But I remember reading that Turing wasn't just about speed, it also introduced that NV switch chip we talked about earlier.
That's right. NV Switch was a game changer. It was like going from a two-lane highway to a massive multi-lane freeway for GPUs. Instead of connecting just two GPUs, you could now link together dozens or even hundreds.
So this is when NVLink really started to become the backbone of those supercomputers we see in movies.
Exactly. NV Switch allowed us to build systems with unprecedented levels of computing power, capable of tackling problems that were previously considered unsolvable.
It's mind-boggling to think about what those systems are capable of. But hold on, didn't you say the latest generation of NVLink is even faster?
Oh, it gets even crazier. The fifth generation, found in the Hopper architecture, boasts an astounding 900 gigabytes per second per GPU.
900 gigabytes per second. I can't even imagine what that kind of speed would look like.
It's hard to even fathom. It's like downloading the entire Library of Congress in a matter of seconds.
Okay, that's officially beyond my comprehension. But I have a question. If NVLink is so powerful, why don't we see it in every computer? Why is it mostly limited to those high-end systems?
Well, there are a few reasons for that. First, NVLink requires specialized hardware. The GPUs themselves need to be equipped with NVLink connectors, and you need a compatible motherboard and system architecture.
So it's not something you can just add to any old computer.
Not quite. It requires a specific set of components designed to work together. And second, NVLink is still relatively expensive. The technology itself adds to the cost of the GPUs, and then you have the added expense of the NV switch chips and other infrastructure.
So it's kind of like a high-performance sports car. It's amazing, but not something everyone needs or can afford.
That's a great analogy. And third, not every application requires the kind of extreme bandwidth and low latency that NVLink offers. For everyday tasks like browsing the web or watching videos, a single GPU connected via PCIe is more than sufficient.
That makes sense. So NVLink is really reserved for those specialized workloads where performance is absolutely critical.
Exactly. Think about things like training massive AI models, running complex simulations, or rendering Hollywood-level special effects. Those are the kinds of applications where NVLink truly shines.
It's amazing to think that something that started as a way to connect two GPUs has evolved into this incredibly powerful technology that's driving advancements in so many fields.
It really is. NVLink is a testament to the ingenuity of engineers and the relentless pursuit of pushing the boundaries of what's possible with computing.
So where do we go from here? What does the future hold for NVLink?
That's a great question, and one that has even the experts speculating. But one thing's for sure, NVLink is here to stay, and it's only going to get faster and more powerful. We're already seeing hints of what's to come with the latest Hopper architecture, which features even higher bandwidth and more sophisticated interconnect capabilities.
It's exciting to think about what the next generation of NVLink will bring. But before we get too carried away, I think we need to shift gears a bit and talk about some of the broader implications of this technology.
Oh, absolutely. We can't just focus on the technical aspects. It's important to consider the ethical and societal implications as well.
Exactly. Because with great power comes great responsibility.
Right? Right. And NVLink is undoubtedly a powerful tool. So let's delve into some of the ethical considerations surrounding this technology and explore how we can ensure that it's used for good. Thinking about NVLink and its impact, it really highlights a shift in how we approach computing.
Oh, tell me more about that.
Well, for decades, the focus was all about making individual processors faster, cramming more transistors onto a chip, increasing clock speeds.
Yeah, the megahertz wars, I remember those days. It was all about who had the biggest number.
Exactly. But we're hitting the limits of that approach. There are only so many transistors you can cram onto a chip, and clock speeds can only go so high before you run into problems with heat and power consumption.
Right, it's like trying to squeeze more juice out of an already dry lemon.
Perfect analogy. So to keep pushing the boundaries of computing, we need to think differently. We need to move away from this bigger, faster, stronger mentality and embrace a more collaborative approach.
And that's where parallel computing comes in. Instead of one superpowered processor, you have many processors working together in harmony.
You got it. It's like having a team of expert chefs working together in a kitchen, each specializing in a particular dish, rather than one chef trying to do it all.
I like that analogy. Makes it much easier to visualize. So where does NVLink fit into all of this?
Well, NVLink is a prime example of how we're making this parallel computing vision a reality. It provides that high-speed, low-latency communication pathway that allows those multiple GPUs to work together seamlessly. It's the secret sauce that makes that parallel processing magic happen.
So it's like the communication system that keeps all those chefs in sync, making sure the dishes come out perfectly and on time.
Exactly. And without that efficient communication, the whole system falls apart.
So why NVLink specifically? There are other interconnect technologies out there, right?
True, there are other options, but NVLink has a few key advantages. First, it's purpose-built for NVIDIA GPUs. It's like having a bespoke suit tailored specifically for your body. It fits perfectly and maximizes performance.
So it's not just about being fast, it's about being optimized for those specific NVIDIA processors.
Precisely. And second, NVLink has a proven track record. It's been deployed in some of the world's most powerful supercomputers and AI systems, demonstrating its reliability and scalability at a massive scale.
It's like choosing a seasoned captain to navigate a treacherous sea. You want someone who knows the waters.
Exactly. And let's not forget that NVLink is a constantly evolving technology. Each new generation brings higher bandwidth, lower latency, and more sophisticated features.
So it's safe to say that NVLink isn't going anywhere anytime soon.
Safe is an understatement. NVLink is at the forefront of high-performance computing, and it's only going to become more essential as we tackle increasingly complex problems in fields like AI, scientific research, and data analytics.
Well, I have to say, this has been an eye-opening deep dive. We've gone from the basics of what NVLink is to exploring its impact on everything from scientific discovery to the way we live our lives.
It's been a fascinating journey, hasn't it? And it really highlights how technological advancements like NVLink are shaping the future in ways we're only just beginning to understand.
Absolutely. But as we wrap up, I think it's important to remember that technology is just a tool. It's up to us to use it wisely and ethically.
Couldn't agree more. We need to be mindful of the potential consequences and ensure that these powerful tools are used for good, not for harm.
Well said. And on that note, I think it's time to bring our deep dive into NVLink to a close.
It's been a pleasure exploring this fascinating technology with you.
Likewise. And a huge thank you to all our listeners for joining us on this journey. We'll see you next time for another deep dive into the world of cutting-edge tech.